presentation, you will learn about what we do. But what do we do? What do we really do? I would say we assist infrastructures, industrial plants in improving the management of the assets throughout the life cycle of the project, from construction to operations, of course. We help companies to ensure regulatory compliance, to control industrial risk. How do we do that? Through the implementation of IT solutions, something we call smart O&M, smart operation and maintenance, combined with expertise, maintenance consulting services. So what we do is a combination of IT solutions and consulting, maintenance consulting, and the two for us always go together. We cannot do one without the other. That's what characterizes our company. For us, risk management is part of operation and maintenance. It's very clear, and I will explain this. Originally, we're a French company, started in 1986. We set up the Asia business in 2004. Personally, as I said earlier, I've been in Asia since 1997. I used to be based in Singapore. Then I've been in mainland China for over 20 years already, doing projects all over the region. So some of you are in Malaysia, some of you are in Thailand, some of you are in Singapore, and I think other countries as well. So I've been working, doing projects in I think in all the countries where the attendees are based. We're active all over Asia, as you can see on the map, and actually outside of Asia as well, all the way to Brazil, all the way to Africa. So we are quite active from China, from Asia, overseas, primarily with Asian investors and Asian EPC companies. I won't go into more detail. As I said, this is just to illustrate what I just said. What do? We implement smart O&M solutions, IT solutions for operation and maintenance through a methodology which is based on the ISO 55000 standard, industrial best practices. And you could take it the other way around. We help customers implement operational improvement with IT. So you can look at it both ways, but as I said, IT and best practices, maintenance consulting for us go together. So we are both a tech provider and a maintenance consultancy. We develop our own software, so we are basically experts of O&M. We went to develop our own software, so we have full control of design, implementation, long-term support, no excuses. That's the approach we have chosen. We have lots of clients in Asia, over 1,000 sites. Many of them are in China, in Greater China. We have a strong focus on environmental and energy projects. So some of you are from our main target industries. We also have a lot of industrial clients, different kinds of manufacturing plants. And you can see some of our recent projects in your countries. I will not read the names on the screen, but I will be using some of them as case studies. I should say that I'm going to go through some of the slides fairly quickly. Don't worry about this. Hopefully you focus on what I say, what I'm trying to say. The slides are in the background. You will get a copy of the slides later. So if there's something you couldn't read, no, don't worry. You can get a copy of the slides. You can read the details later. You can read the things I didn't say in particular. I'll take 1 or 2 minutes to introduce and to thank our partners today for this event. As you know, I think some of you have been invited by, not directly by Siveco, but by our partners. We have 4 partners joining us today, 2 our associations, 2 our industrial solution providers. Let me just say the Asia Pacific Urban Energy Association. We've been working with them for many years. They gather urban energy utilities and equipment or solution providers. They generally promote the development of district cooling, in particular in Southeast Asia, and heating, district heating, more in the north of Asia. And through seminars, through a very good magazine, and through activities with their members, which include our company Siveco. So that's the Asia Pacific Urban Energy Association. We also have the Franco-Thai, French-Thai Chamber of Commerce. They are Chamber of Commerce, part of the network of French chambers in Asia. Well, their main mission is to put together French companies in Thailand and let's say, the ecosystem of French companies in Thailand and promote French investment in Thailand, Thai investment possibly in France, and cooperation in general through seminars and other activities. So thanks to the Asia Pacific Urban Energy Association and the French Chamber in Thailand for being with us today and for inviting the members, and hopefully there'll be more activities. Then we have two industrial solution partners which provide solutions complementary to ours. And we've been working with both of them for actually a long time. Setim Matcor, based in Singapore, the Asia headquarters in Singapore, is originally a French company. They provide technical expertise services, in particular well known for testing, material testing in particular, and related engineering services. Incidentally, my first working experience was with them in France in 1995. I was still a student, so I've known them for a long time. So we have customers in common, and we sometimes work together on projects. And ACOM is another French company and a well-known provider of condition monitoring solutions for rotating machineries, vibration monitoring solutions, and environmental monitoring solutions. Initially noise monitoring, because their background is vibration, but also pollution monitoring. Again, they have been our partner for many years. We work together on projects in China, actually, and we've been cooperating in Southeast Asia as well. Their main office is in Bangkok. So we have actually a strong Thai taste today, which is nice, because for me, Thailand is a country where we are we're very active, although unfortunately we cannot travel that much these days. And the same could be said of the other countries in the region. So that's for the partners. Again, thanks for joining us, to partners and all attendees. And I'll be sharing these slides so you'll be able to find more information about all of us later. Let me jump now into our topic, risk prevention. Rather, I'll be trying to explain the link between risk management, risk prevention, and maintenance or asset management, because this is where I come from. Industrial maintenance. And for some of you, the two topics might not be well connected. For others, you will say, well, it's obvious, we know. But let me go through that before the case studies. The background to this event, and very unfortunately, is there's been a number of industrial accidents in Southeast Asia in the past weeks, past month. And well, the picture is of this chemical factory fire near Bangkok airport earlier this month, or beginning of July, actually. And more generally, we live in a dangerous world and in very uncertain times for over a year now. So different countries have different situations, but COVID-19, all of us face it. And of course, most of you operate industrial plants, dangerous, hazardous environments in different ways. But industrial disasters have made headlines recently. We in the industry know that headlines doesn't mean that we have more accidents suddenly. It's just the coverage of the accidents is there, more public attention, maybe more regulations coming. It's probably good somehow. But anyway, that's the background, and that's also why we do this event now under the topic of risk management. Now, for me, having been in China for 20 years, and our main resource center for the business for Siveco is being here in Shanghai. We've been through what is the picture here? China 10 years ago. We've been through a period with many accidents and a very strong very strong media coverage of accidents, and it started about 10 plus years ago. And the regulator, the government, came in very strongly, putting pressure on companies, coming up with new regulations, very strict enforcement, very harsh enforcement, plant managers ending up in jail, forced consolidation of certain industries, for example, storage, chemical storage terminals. Companies had to consolidate, the big ones had to buy small ones, so that the industries would be easier to control. So very, very strong changes in the industry. And we, Siveco, have been through that, and we think we've learned a lot in this process, which is where I'm coming from, and this is partly what I will be trying to share with you. The picture here on the screen was a massive explosion, a fire in a chemical storage terminal in Tianjin in North China, a major disaster. But there were many like this. So that's the experience of Siveco has been shaped by this situation in the Chinese market, and I think a lot of it is relevant elsewhere. And there's a few findings, things we've learned that I'd like to share here, and that to make the link between, again, risk management, maintenance, technical management, and a lot of this for some of you is not new, but again, in many companies don't link risk management and maintenance. The two tend to be disconnected. This is how we entered the field. When 10 plus years ago, clients in China facing huge pressure from the government, from their shareholders or stakeholders, but primarily from the government here, to improve safety. To improve HSE in general, safety and environmental compliance. Very strong regulatory enforcement, lots of audits. And around 2009, as far as I remember, we had companies coming to us, and the main driver for them talking to us was not maintenance itself, although we were positioned as a maintenance consultancy and as a supplier of maintenance management system. They came to us with the need to improve safety, to demonstrate compliance to the authorities, to demonstrate that they were doing the regulatory mandated checks as per the regulation and so on. And we started to think about this as a consultancy. So this is what I want to share here. Of course, one of the first things we saw, and actually based on government investigations in China of those accidents, the many accidents we had here, the idea that technical mistakes, technical errors were the cause of most accidents or a major contributing factor. Technical mistakes, what are they? Wrong diagnosis leading to a wrong decision by a technician, or a maintenance technician doing something wrong, thus creating a hazard for the plants, and of course bad management decisions. Misguided cost reduction is a typical way to make bad decisions. So generally, mistakes in technical decisions, either at working level by a technician, by an operator, often due to a lack of knowledge of what they were doing, lack of knowledge of the impact or the potential impact of technical actions, and mistakes by their managers who have to make a technical financial decision, but maybe don't have the right data, don't have the right knowledge, and end up making the wrong decision. So again, technical mistakes as a primary cause of safety problems or accidents. On the other hand, HSE being intertwined with maintenance, with technical management, with technical activities in the plant. Obviously, I mean, some of you coming from chemical industry or utilities, where incident reportings, that's something your operators and maintenance people will be doing because they will be able to identify problems in the plant. Work permits, you don't do something in the plant without appropriate work permits. Isolation procedures, LOTO, lockout, tag out, proper use of personal protection equipment when you're in the plant, and so on. So HSE is part of everything you do, and then everything you do has an impact on safety and the environment. So there's a technical reality behind the link between risk management and maintenance, of course. That's maybe an obvious finding. More interesting, when we started to face customers telling us they wanted to manage the technical risk, we were a bit hesitant. We, coming from a maintenance background, we were thinking like, well, we don't know about risk. You know, there's a standard called ISO 31000. This is very mysterious for us. You know, ISO 31000, this must be a very complex standard with very advanced concept. So we went to read the ISO 31000 standard, and we went to study it. And then we discovered something very interesting. The basic definitions, you know, risk, what is risk? Risk is the effects of uncertainty on objectives. So what are the objectives of the company? This is the first question. This is a very interesting definition that most people ignore. Then, of course, we can look here at what is maintenance. And then you can see, you can immediately see the link. Maintaining items so that they perform the required function. Required function is related to the objectives of the company. Same thing for asset management. It's a lot of confusion. What is asset management? What is maintenance? For today's purpose, I would say they are the same thing. So of course, maintenance is about the technical activities required to make sure your plant can perform as per the objectives. So we're talking about risk management here. There's something interesting in the definition of maintenance according to this European standard. You see the items under the maintenance department responsibility. But so people sometimes think the maintenance department is in charge of maintenance. Then maybe HSC department is in charge of safety. Maybe operators, the operation department is in charge of something else, operations only. But in fact, everyone is in charge of different items or assets in the plant. So in a sense, everyone is also acting as the maintenance department. This is, if you dig up these standards, you will find this concept. So risk management is not that mysterious. And if you go deeper into the standard, and we did that in 2009, we discovered something rather fantastic, that the risk management standard, the ISO 31000 standard, and was referring constantly to our well-known maintenance standards. And this was a key finding. And if I encourage you to look at these standards, and they are not so easy to read because they are quite general. But in 31010, which contains more practical guidelines, you find a list of recommended methodologies to manage risk. And the top ranking methodologies are all well-known maintenance methodologies. We're talking about root cause analysis. We're talking about failure mode and effect analysis. We're talking reliability-centered maintenance. So when we started to look, as maintenance consultant, when we started to look at ISO 31000, we discovered that we had always been doing risk prevention, that we had always been compliant with ISO 31000. And that's very interesting, which is why I will actually refer to another standard, ISO 55000, which is the asset management standard, which goes a little bit more into practical details compared to ISO 31000, and proposes a risk-based approach to asset management or to maintenance. So again, I won't go into too much details here, but this convergence of standards between risk management and maintenance is a very interesting phenomenon, which proves that the two are strongly related. Of course, we knew it. If you've been working in maintenance, and some of you are maintenance managers, some of you run large plants, you knew this. When we talk about maintenance, we talk about risk prevention, avoiding what you see at the bottom of the iceberg, avoiding problems, downtime, accidents, unplanned costs, non-compliance, of course, and we will come back to the topic of regulatory compliance. So we knew it. The other thing I want to say about maintenance is a kind of an ugly duckling. Depends a little bit which industry you are from. If you're in a very large chemical plant or in a power plant, the maintenance manager has a high position, and maintenance is recognized as an important function. If you are maybe in an automotive manufacturing plant, maintenance tends to be a little bit on the side. Which is why today we don't do a webinar on maintenance. We do a webinar on risk management, which is a higher end topic, which attracts management attention more. But actually, the two are basically the same. Risk prevention is the objective of maintenance. There are other standards. I will refer to some of them. I put a list here, and you can get it. Some standards are much more practical than others. There's one that I like very much, ISO 14224, which is a very practical standard. And some of you will think it's a little bit too practical, too technical, and it's not. It doesn't say it's risk management related, but it's much more practical than ISO 31000, for example. So to actually do things for risk prevention, I recommend that if you want to read a standard, want to read a standard that engineers can understand, this one, ISO 14224, is a good one. And there are a few others I will be talking to when we look at the case studies. That's the first thing. Second, the weak link is people. That's us. We often hear, about human errors. The problem is not machines. It's people. If the machines are wrongly designed or wrongly installed, it's again because of people, right? So we're talking about the mistakes of technicians, operators, managers, you and me. And that's the first thing. So the weak link is people. People are hard to deal with. How do you improve how people work? How do you bridge the knowledge gap? How do you train people? Maybe you're facing a high turnover. Maybe you're facing difficulties to hire people. How do you ensure your people are trained? How do you ensure that they follow the rules? How do you ensure that they follow a methodology for troubleshooting, diagnosis, for example? How do you help your managers to make decisions? Based on which KPIs? Based on what data? How about the other stakeholders? The auditors, the government. They're also people. They also make mistakes. How do you deal with that? It's of course very hard, but that's where this is the weakest link. So how do you do that? You should take this into account. And of course, 4.0, smart plants, digital twins, robots, whatnots, don't make things easier. Our plants are becoming more complex, more automated, more computerized. They require even more qualified people, people who are even harder to find, harder to train. And we've been through that in China, of course, with a lot of new plants built in the past 10, 20 years. And of course, when we build a plant, we build a high-tech plant. So technology doesn't really help, and technology make actually the plant more dependent on maybe less people, but more qualified people. So how do we deal with people? So that would be a key part of my story and the case studies, and because we have to deal with this challenge. Number 3, I've been talking about maintenance, asset management, risk management. And I said earlier that we as a company, Siveco, we believe that we can use IT, digital solutions, smart solutions, what I call smart O&M, to help dealing with the challenges we face. Now, of course, in particular in Southeast Asia, and among your companies here attending today, a lot of you have already implemented IT solutions for maintenance, for asset management, for technical management. CMMS solutions, computerized maintenance management systems, or so-called EAM solutions, enterprise asset management systems, or an ERP system with a maintenance module. Some of your companies have spent huge amount of money and many years to implement very advanced systems. And that's very interesting because we see in many cases those solutions, those projects, IT projects, do not address our risk management needs. They do not address the needs highlighted by the ISO 31000 standard. They do not address the needs highlighted by the ISO 55000 standard, the asset management standard. I have an example on the screen here, this radar chart. It's based on an audit we did in a large power company in Thailand, and I don't put their name here. So this is the result of an audit. I will comment it a little bit. You see some areas are in orange, some areas are in blue. Blue means very good coverage of the need by the system that they have implemented. Orange means very poor coverage of the need. And on the different axes, you see basically the key areas identified by ISO 55000 and by the customer based on their objectives. Remember, risk is related to objectives and based on their needs. So I don't go through the chart in detail. I just want to say that on the bottom left, the orange parts, you have those areas related to improvement and risk management, and the coverage is very poor. And on the top right, you have more administrative, cost control, approval type of things, workflows, cost tracking, time reporting, and you see a very good coverage. This is very typical of most software, maintenance software implementation in the industry in general, in Southeast Asia, and it was the case in this utility company, but you'll find almost the same shape of the chart in almost every company. What does it mean? IT systems primarily focus on what I call admin, cost control, workflows, approval, things that IT people understand well, actually. And what we need in terms of risk management is typically not covered very well or not covered at all. A key area here is inspection. Those of us in the industry, and I will come back to it in the case studies, know that inspection is actually very important. You go in the plant and you look, you do an audit, it's an HSE audit, it's a daily inspection by operators, it's an inspection mandated by law, by the regulator, and different types of inspections. They are very important. It's a key part, and there may be the most important type of preventive maintenance. And it's typically not covered at all by the big IT systems that most companies implement. But this is perhaps one of the most important part of a risk management system. And in most cases, managed on Excel spreadsheets, on paper, or with a small IT system, built with a very small budget, or maybe developed by an in-house team. The other thing you see here is decision support. So having the right data in the right form so that you can make a decision. As I said earlier, one of the main cause of accidents, problems, non-compliance is a bad judgment, a bad decision, either by technicians or by the managers. And typically, most IT systems, and it was the case in this company, you cannot get any valuable output in terms of supporting a decision from the system. A practical example is also this one you see here, a failure cause. It's a very striking example. Again, this is very typical. This chart is actually not from the same company. This is based on a survey of many customers over a period of several years. This is something we did a few years ago. 88% of the failure cause, the cause of a failure, maybe the impact of the failure in IT systems we have audited, 88% is either something like other or it's empty, which means 88% of the data in the system is not usable to make decisions. 88% basically means the entire system is worthless in terms of making decisions. So if you don't have a useful database of failures, of problems, incidents, which you can analyze for improvement, how do you improve? You cannot. Most companies in their IT system, they just report a text, oh, something is broken, please come and fix it fast. This kind of text, which is useless for improvement. So knowing that, we want, of course, to take action because a lot of money has been spent on such IT systems. So what can we do? So 3 main findings of finding errors. It's a bit sketchy. I didn't go into too much details, but I think a lot of you, based on your experience, based on your profile, can actually recognize some of what I say. So that being said, I will go and look at my case studies, which are simply a way to illustrate what I said on real cases and try to answer the question, what do you do with that? What do you do when, for me, when a customer comes to me and say, well, we need to do something because we're facing regulatory pressure. And we need to show that we are doing everything we can. Or recently, again, it happened, a customer had an accident in a plant, a young engineer got hurt, very badly hurt. And they say, but we thought everything was all right. We have our internal process. Look at the beautiful folder, Bruno, with all the regulations. And we train every employee, and then we have an accident. And then we went to look at why we had the accident, and we found actually we don't follow our best practice. We don't follow our working process. What can we do? So I have a few case studies to try to illustrate this, and illustrate this within the context of, I was going to say the context of COVID-19, but this is our life today. Knowing that we cannot just wait. We cannot just wait for COVID-19 to be over. I mean, some of you have been waiting already for 1 year and a half. And then what next? What next problem are we going to have? Unrest, the riots in the street, and there may be a coup and changing of government, and then what else? There's always problems. So what can we do now? What can be done now? And maybe what can be done better under the pressure and the challenge of the crisis. That's what I try. That's what we try to do, of course, and I think all of you do as well. These are, I put there the logo of the few customers I'm going to use to illustrate my point. Depending on how efficient I am in the presentation, I might some of them I would go very, very quickly. But we picked clients which I thought would be relevant to you in terms of their location and industry. The first one is a joint venture between a Belgian company, LBC, and Costco Shipping, a big Chinese company. It's a terminal. It's an oil and chemical storage terminal in China, in Shanghai. I choose a terminal because part of my story was all the big accidents in China, and storage terminals were part of this story with major disasters. So it's an example of a customer facing huge pressure for improvement. Then I have a few manufacturers. I have Essilor, the optical lens manufacturer. We've been working with them in multiple locations in China, in Thailand, in Laos. So it's relevant for you in different countries. Showa is one of our customers in Malaysia. They make graphite electrodes. So it's a process. It's a big process plant. It's actually a Japanese company that acquired a German company, and we work with them in Malaysia. In the Malaysia plants. I have Chonburi Clean Energy in Thailand, in Chonburi, which is a waste to energy plant, a waste incinerator producing energy. I have Suez, a plastic recycling plant outside of Bangkok. And I also picked a utility client. I forgot Marelli. Marelli is an automotive supplier. They make Italian company acquired by a Japanese company that they make car parts. They're a tier 1 automotive supplier. We work with them in China and in Malaysia. And then finally, I picked a water utility to illustrate environmental compliance. This is a municipal utility, a government company in China. Picked a Chinese company because we have a huge market share in water, municipal water utilities in China. Is the water company of Zhongshan in South China. It's a large city in South China. Okay, so there are different priorities. I will try to explain what kind of different priorities you can have in terms of risk management. Not everyone has the same risk because it's related to your objectives and your industry. Different phases in the life cycle of the assets. So I'll be talking about this as well, and in different industries and locations, as I've just said. The first one and my introductory story is really this one, LBC Shanghai Shipping, which is a joint venture between an international investor, a Belgian company, and a huge Chinese company. They operate a chemical storage terminal on the sea in Shanghai. And we started to work with them in 2016, and they were facing huge pressure from the government due to too many accidents in this industry, in many terminals. So they came to us. For this reason, and the CEO of the company actually contacted us to see how we could help to ensure compliance with the regulations and to reduce their risk, to try to avoid accidents, knowing that they have a hazardous process and that they were under scrutiny by the government. So the CEO called us, and that's very typical. Many of our projects are initiated by the top management because top management is aware of risk. They had a maintenance management software. So their technical management, their maintenance was managed by software for many years already. And certainly the project was not initiated by the maintenance manager because, well, he was happy with the current situation. Actually, he didn't see the need. The call really came from the CEO. They had a software which I would say is a typical local CMMS. You know, you have small suppliers in many countries, and more and more cloud-based software suppliers as well, but also more traditional PC-based suppliers. And the typical small CMMS, you know, has a lot of functionality, but this doesn't go very much in depth, and it's mostly kind of admin-driven, meant to replace a paper process. So, but it's good. So they had such a system in place, and for what I call regulatory reporting, mandated preventive maintenance inspections, they were using a paper-based process. Somehow it was not part of the CMMS, mostly because they thought the regulator wanted to see forms based on the standard format given by the government. So they were using paper. The problem of paper is you have zero traceability and zero proof that what you write on the paper is the truth. So you just write whatever you want on a piece of paper. Whenever you want, you finish the job, you go back to the office, you write a piece of paper, or maybe you forgot to fill in the piece of paper, and 5 days later you fill in the paper, or maybe the day before the audit, wow, our documentation is not up to date. Let's go and create some fake records. That's the problem with paper-based records. So we did what I call a mini audit of the situation. What is a mini audit? A mini audit means we don't spend too much time doing the audits, because typically we find most customers have actually the same problem. So we quickly identified the need, and they decided to launch a project to quickly strengthen the risk management process at the terminal. So a key word here was to do something quickly to start improving their risk management, and we choose ISO 31000 as a framework, but there's not so many frameworks around. There's not so many top-level standards around for risk management. What do I mean here? I wrote deliberately using ISO 31000 is you want to use a framework that is recognized. So when you face your regulator, when you face your stakeholders, you can say, look, we try to work based on a recognized standard. It has nothing to do with getting certified, by the way. Here, I'm not going to talk about how we get certified. That is not even the point. It's more having a framework that people can believe in, and that is recognized as a good framework. And this is what happened in the projects. And that's, I think, very typical of a risk management approach for technical risk management. We went through a systematic identification of equipment, physical assets, and define, rank them based on how critical they were. I won't go into defining how to define the criticality of an equipment, but this is a key part of the risk management approach. You want to prioritize based on risk. So we went to look at all the equipment. We inventorized all the equipment, and we went to systematically defining the criticality of equipment, which I should say can also change over time. So you don't have to worry that maybe you didn't cover 100% of the requirements, 100% of the equipment, and maybe you forgot some critical equipment, but you start somewhere. Then you say, well, 1, 2, 3, they are critical because I know they are critical. Or they are critical because the laws, the regulation says they are critical. They are regulated type of equipment, pressure vessels or whatnot. You start there, then you can always improve this. And we put QR code tags on this equipment to have a way to identify the equipment. Okay. Then we implemented a mobile app. So part of our system is a mobile application running on explosion-proof hardware, which is necessary in this kind of facility. So it's a special mobile phone, basically. And then the purpose of this was that operators and technicians would report any non-compliance, any problem directly in the system in a very structured way. That's the topic of diagnosis, actually. When you see a problem, what methodology can you follow to make a decision, to actually diagnose the problem? And first is, how do you report the problem? So the methodology, let's say, to report a problem. Most people don't actually follow a methodology because they just write something on a piece of paper, or they just call, or they rush back to the maintenance department. So we implemented an app for this, and we started to use it, and it relies on scanning the QR code and reporting the problem. And then for inspections, we mandated scanning of the QR codes. We wanted to make sure and to prove that regular inspections, and then later that regulatory inspections and work, preventive maintenance was done. We wanted to prove that the work was done. And a good way to do this is to actually have people to scan. Of course, you can scan and still not do the job. That's possible. But we found that in practice, people are not, most workers, they're not bad people. If they don't do the job, it's because they thought there was an emergency somewhere else and that preventive maintenance job can be delayed. They sincerely thought so. But by forcing people to actually go to the point of inspection and to scan and to take a mandatory photo, you give them a very strong incentive to actually get the job done. And in our experience, it works quite well. And the data goes in a central system, which was installed in a cloud. It's a Siveco cloud, so that we can analyze the data, and together with the customer, where we took them through a process of regularly reviewing the data in the system, reviewing non-compliances, incidents, and then step by step improving the ranking of critical equipment and developing actions, corrective actions, preventive actions. That's the idea. We did the project in 3 months. So again, the idea was to go fast, to have in place a loop, an improvement loop, and something that you could demonstrate and you could tell the idea was they could tell their stakeholders, their shareholders, the Belgian company and the Chinese company and the authorities that look at what we are doing, to gain control of our risk. That was actually the goal. And then we built up based on that, based on having feedback from the field. It's been a quite successful project. It's always very hard to measure the success, the result of a risk management project, because you can say, well, there was no accident. Well, this terminal had no accident, even no incident for many years now. But you can say, but who knows? Is it because of your system, Bruno? Is it because of your project? Who knows? You know, I certainly don't know. So it's hard to prove like this. But a process has been put in place and demonstrated many times and convincingly with their stakeholders, including the regulators. And that's very important. And when people always think the regulator wants to see, you know, pieces of paper in the standard form, and regulators are not stupid. And actually, if you can get the data directly from a system, where the system actually proves that the data is accurate, unlike the paper system. And then the regulator usually is fine with it, and we have a way to print data from the system into a standard format as well. So this is not a problem, but having a system that you can demonstrate, and they have done it quite successfully, and they actually got shortlisted and nominated for an award, a global terminal award, a global meaning worldwide. They actually didn't win the award, but they got nominated at the time where Chinese terminals worldwide were under some kind of bad press, I would say. So this in itself is a good result. And finally, the Belgian shareholder LBC sold their shares to the Chinese shareholders, which was actually also one of the goals of one of their goals. So they successfully sold the company, partly thanks to their good management practice. So it's a typical example, again, doing a quick project and to achieve a demonstrability of the demonstrable risk management. Well, the system we put in place, I won't go too deep into this, but the system is this, what you see on the screen is a platform called Bluebee Cloud. In the customer I just mentioned, it's really on the cloud, we manage it, but for many customers, we install it on their servers. That's up to the IT policy of the client. It differs from one client to another. All can be done, and basically it's a central database, a structured database of data. You could say it's a maintenance management system. You could say it's an EAM system, enterprise asset management system. Indeed, you could say whatever you want. It's also a risk management system. It's a platform that can manage all these different things and get the data out. It's a tool, I say, to structure the project and to train the team in some concept that maybe they have not heard before. It's a practical training tool, and it's also a tool to motivate people, because when you have a beautiful IT system with beautiful pictures like this, you are more likely to use it. The other key part of such system is the mobile part. You want to touch the workers. You want to touch the people who make decisions and who do things on the field as the workers. This is you and me. This is the people in the plants and the managers. So the mobile part is very important as well. Again, it has to be very user-friendly, very easy to carry. So we have it running on mobile phone, and having a proof of doing the job is the most important when it comes to regulatory compliance. So scanning of a QR code, scanning of NFC tag, RFID tag, taking a picture are usually mandatory, but for most, at least for regulated or important actions, so that you want to prove that the guy's been there. So if, unfortunately, if there is a problem, you can prove to the regulator that you have done all you could. And maybe indeed it's a personal error of this guy or that guy, or it's related to something else. But this is not the management fault. This is not the company's fault. My overall management system is working well, so you don't need to put the general manager in jail or to close the plants. So this is, you know, it's what I'm saying here is a little bit sketchy, but this is the point. So how to enforce best practice, help the workers. So the app is designed to help the workers and to prove that the work is done. Then, of course, you collect a lot of data by having your operators and technicians equipped with this. I mentioned collecting incidents and faults, failure information. So you get a lot of data that you can analyze and show, as I said earlier, to show to your stakeholders, show to your shareholders, show to your boss, show to the mayor when it comes to visit the plant, show to your clients. If you're an automotive, I will show an example of an automotive company, show to your clients, the car maker when it comes to audit you, and use to make decisions. You know, in most companies and in many of your companies, technical management is invisible. The top manager doesn't know actually what's happening when it comes to technical management. You know, you all have a big board at the entrance of the plant showing how many days without incidents and so on, but the details are not known. Who's doing what? Minor non-compliance? Are the inspections done or not? Is the preventive maintenance being delayed, and why? usually the top management has no visibility in this, and visitors to your plant have no visibility into it. So the idea is to make it visible, and many of our customers put it in the entrance of the plant, in the lobby, put a big screen like this with real-time data. Essentially, what we are doing is to close the loop, what I call the ISO 55000 or the ISO 31000 loop, connecting what's happening in the field with the strategy. This is the most difficult part of implementing the risk management system, in our opinion. That was my finding number 2, that the people are the weak link. So how do we deal with that? How do we help the people? How do we get data from them? That's the idea. That's what I call the loop. There's a little movie here you can see. You can see later on YouTube the full demonstration and stories from a customer. So that's what we did with the terminal, and I will briefly show other customers. But now I've been talking about a tool, IT tool, and I know how it is. People start to think this is about IT. This is very interesting technology. Maybe I want it, or I already have. This is not about IT. IT is only a tool, and we should keep the objective in mind, which is risk management, and risk management depends on your actual objectives, the actual situation in your plant, and then we build the project based on that. So it's not an IT project. It's not about the beautiful functionalities of the system. It has a lot of beautiful functionalities. That's not the point. It's what's the objective. That's really our thinking here. That's why I want to emphasize it. Essilor was a different story, a company with different priorities, different risks. They make optical lenses for glasses, multiple plants. It's a large company. It's a very complex production process. Actually, people don't realize, but making lenses for glasses, you have to trace each lens independently to make sure it goes to the right customer in the end. So throughout the production process, they track individual lenses. So it's a highly computerized process with lots of different machines. It's a kind of discrete manufacturing process with many machines and highly computerized. So if you have a downtime, a breakdown on a machine, it has a huge impact on the supply chain, especially because of this traceability and uniqueness of the products. But I won't go too deep into the process itself. But downtime, eliminating downtime was the key issue. We started working with them in China. And they had, we defined with them an improvement strategy. This is a triangle that you see. First you build up your best practice and your plant database. Then you go up in the triangle and then all the way up to analyzing and improving your maintenance plan. That's a normal improvement strategy, you would say. Then we found, of course, if you do this to build the base of the triangle, the work is huge, especially in the large plants, to build up all this technical database. To build up the maintenance plan, the preventive maintenance plan, if you don't have one. This is a huge project. It might take 2 years in a big plant. So do you want to work for 2 years before you see anything? No. So we did something different. We go through this triangle quickly. We start with a basic technical database, level 1. Then we jump into level 2 to record incidents, breakdowns in the plant. So a little bit the same story I mentioned before. And that's how we started the project. To have a systematic recording of failures so that we could do analysis using a methodology. So we used a standard with a methodology, and we implemented it through the system, including through the IT system, similar IT system as you have seen just now, to start having data that we could analyze together with the client, on which we built the preventive maintenance plan. The result has been very good. These are the numbers from the Shanghai plant, and then we did the same in. Then the project went on to Thailand, to Laos, and then in the Thailand plants. But you can see a very good improvement in terms of downtime reduction. For them, that was the main risk to control the downtime. And they do something which they're very happy to do is when they get audited by their clients, by their group. Mostly it's not by the regulator in this kind of industry, but it is in some areas. Mostly they get audited by their group company or by major clients. They can demonstrate compliance with their standards with one click, because they have real-time data in the system of everything that they do, faults, but now also preventive maintenance, up-to-date equipment database, and so on in very large plants. So one-click audit report is what they would emphasize if you ask them. People sometimes ask, when do we start a project like this? The best time to start is if you're building a new plant. Okay, the earlier the better. But the best time to to start to build your risk management process is during the design of the plant. So this is an example in Thailand. Chonburi Clean Energy is a waste to energy plant. I know I'm exceeding my time here. I'll go a little bit faster, but I just want to emphasize with in Chonburi, we involved, as we involve in many projects during the late design phase, to specify the entire system to ensure compliance with, let's say, best practices. And here, this is a company with multiple shareholders, and they had best practices in different areas from the different parties. They had different roles in this project. So how do we ensure that this plant runs as per everyone's best practice, and how to demonstrate it? So start early as possible. And my advice, if you have a construction project, is to design a project with us, a risk management project or maintenance management project. Design the project to achieve payback, return on investment upon startup of the plant. Through the handover between construction and O&M, we should be able to design a project where you can get your payback. So that means the budget, the cost of the project, and what we put in the project, we can design it in such a way that you get payback right away upon startup, which is good. It should be, in my sense, an objective of such a project. What we did here, we started this before, we finished the main project before COVID-19 arrived, but we did a second phase of the project with a mobile solution. So when the plant was up and running, we went in to implement our mobile solution for inspections and work management, as I described before. This phase was done entirely remotely because you had lockdowns in Thailand, and we had lots of restrictions, and we could certainly not travel. My team could not travel from Thailand. Everything was done remotely, and it worked well. So work can be done remotely. It's another way to look at this. So the earlier, the better for a risk management project. That's the essence of risk management. You want to prevent risk. You want to start early. Now you will tell me, if my construction has already started, is it too late? No, we can start now. And if your plant is already up and running, is it too late? No. So the second best time, apart from design stage, the second best time to start a project is now, right now, even if there is a lockdown. Of course, I'm a supplier. You know, I want the money fast, but I want the project fast. That of course. But you know, generally, if it's a risk management good practice. You want to start doing something now. Another example, similar case involving during the construction of the plant before startup, and this project was done entirely under lockdown. So for my team, totally remotely, working with the client team, which actually is a good way to work because the client is on site in their plant whenever they can. A lot of the work was done with people sitting in their home, joining a course, this kind of course. Actually, we all know it works quite well. It can be done. And a fairly successful project because the system was up and running before startup of the plant. And now we still do regular audits remotely through the system. So when you have a system in place, which is a comprehensive system, you are able to audit the plant through the system. Of course, it's not 100% perfect. You don't cover 100%. The system doesn't see 100% of what's going on in the plant, of course. But it does, if it's designed properly, you have a fairly good idea of what's actually happening in the plant. So then we can audit remotely. We can audit, and the shareholders, different stakeholders of the plant can also audit remotely through the system. I will go very quickly through this. A customer in the automotive industry, again, compliance with internal rules. In their case, is the world-class manufacturing process. How do they demonstrate that they are world-class based on their WCM process? And they have, this is a company which is an SAP customer, like many of our customers, a big IT system, SAP, that does everything fantastic, beautiful system, you know, that takes 10 years to get implemented and cost many, many millions. We are all very happy about SAP, but to demonstrate compliance for WCM, everything, paper, Excel, PowerPoint, you know, small hands, cut and paste, you know, totally outside of the system because SAP could not handle this. So you could say we built a system for that on top of SAP to demonstrate compliance with WCM. So they get, a little bit like ACLO, they get the one-click reports based on real data to demonstrate compliance, and also towards their clients. In the automotive industry, as in some other industry, the client, the car maker, comes to see the car part supplier and we audit them, requesting to see an up-to-date asset list, looking at preventive maintenance plan and the execution of the preventive maintenance plan, looking at failures and faults that occurred in the plant and the corrective actions taken. They want to see traceability, and it's hard to do without systems. So this customer achieved this. We are working now with 6 of their plants and expanding into other plants. There's a total of 15 plants, including one in Malaysia that we started to work with a few months ago. I will close with that one, which is a water company. When we started to work with them, we actually talked to them about how maintenance was important. And we met the chairman of the company. The chairman said, you know, he doesn't care about maintenance. He doesn't want to hear about maintenance. His only concern was water quality. They are a water supply company, you know, drinking water. So his only concern was water quality, because the government could hit him with a very big stick if they don't comply with the water quality requirements. That was his only concern. He didn't see the relationship between water quality and technical management. You know, good guy, but in his position, he didn't see the link. Okay, so we went through a project to try to improve water quality, or to guarantee water quality. Again, risk management project, very clearly stated risk. And then we went through the project. Frankly, the content of the project is very similar to what I just described. And in the end, we went to touch into technical activities, of course, because water quality is very much related to technical activities. So fairly successful project as well. And we've worked a lot with environmental compliance concerns. So it's another type of risk, which is, of course, predominant today. I think if you work in the industry, most of you are subject to environmental regulations. I won't say anything about this, but we were with this customer, we were able to use, because so much data accumulated in the system, we're able to use machine learning to do some interesting stuff with the data. So for IT people, this is quite sexy. It's quite interesting, but this was not the main point of the project, so I will skip it. I will also skip this one. Another project we did entirely under COVID. So all remote. A lot of things can be done when you cannot work in the plant. Even when the plant is shut down, they were shut down for several months. We had people working at home. They had their engineers working at home. What do you do when you're at home? You know, you can sit and worry. You can wait before you can go back to the plant, but a lot of work can actually be done. So we did a lot of work with them during the lockdown, and it was good. I will skip this, some screenshots. I will also skip this. So I'll conclude, and I will answer some of the questions. This approach generally works quite well, and we do because we do a lot of audits and follow-up audits and customer satisfaction survey. We see actually it works. What works? What works is this loop. When you're able to close the loop between what's going on in the plant, what technical people do, and how the managers decide. So the ISO 55000 loop. When you do this, you start getting very useful data, which you use to improve. Even if you start from very low, even if your equipment database is wrong, even if today you don't have a proper preventive maintenance plan, but by starting to collect information, you can study, discuss, and improve. So that's what makes things work, and that's our focus. Demonstrating compliance is key. That's part of the loop. You want your top manager to see what's going on. Okay, then they will start asking questions. But some of you maybe want to hide from the top manager. Okay, that's fine. But if you're in this improvement, if you have this improvement ID, or if you're the top manager, you want to see what's going on, and probably your regulator, your client, the government wants to see as well. So we've designed solutions and we implement solutions in that angle, that idea of making things visible. And these are some examples here. Okay, and of course, HSE is not separate from technical management or O&M. It is altogether intertwined, as I said earlier. I have a couple of guidelines. This is my last slide. A lot of this I said already. It's just a summary, so I will not repeat. I will go to the end here. I mean, everyone is under pressure to control risk, especially in difficult times. You are also probably under pressure to reduce cost, but it's related. The biggest costs are when you have an accident or when you cannot produce, and so on, of course. And some companies, unfortunately, are also in a very difficult situation where maybe they can do nothing. Okay. But a main challenge we face, or let's say a pitfall, is to delay the decision, where we'll delay until things get better. We'll delay until next year. We'll delay until COVID-19 is over. We'll delay until the government is stable. We'll delay until I can hire a good maintenance manager. And we have customers like this, or they are not customers actually, but we know companies like this that have been delaying projects for 10 years already. And there are other companies that actually can move faster, and perhaps, I mean, who am I to judge, but perhaps this will give them a competitive advantage, especially in a crisis. Another pitfall is people tend to be obsessed with technology, or we all admire technology 4.0, digital twins, you know, wow, magic, and we can get budget for this, or maybe we could before the crisis. But this is not, it's not just about technology. Technology maybe is a tool, but we recommend to focus on people, the people who make the mistakes, the people who make the decisions, you know, technicians, decision maker. How do we serve these people with technology? And having a 4.0 plant is not going to solve all your problems. Actually, it's going to give you more problems because you have more sensors, more high tech in your plant, more breakdowns, which are more difficult to diagnose, which are more expensive to fix. So you probably have more problems with a 4.0 plant. Okay, and we're talking about IT. So IT people will be involved at some point in the discussion. We have to be careful with this without conflicting with them. I say some of my customers are SAP customers, so they have very big IT departments doing very big projects. We cannot be in conflict with these people. Otherwise, we're dead, our project is dead. So how do we cooperate with them? How do we bring value to them? And how do we avoid, you know, making projects too complex and that in the end, they don't serve our needs? Use ISO 31000, ISO 55000, because people will believe the standard is a credible standard, and we can use this to prioritize the content of your project. We have done this a lot working with IT departments. It works quite well. But of course, you have to have a practical understanding of the standard. You cannot just read the standard. But we have a lot of practical experience with this. And the last one I already said, but sometimes we see companies that come to tell us to say they want to do an HSE project. Do we have an HSE software? Well, we have, but you cannot disconnect this from maintenance. You cannot, although there's an HSE department, and maybe they are very clever compared to the maintenance department. Sometimes we hear these kind of things. But these guys have to work together, and HSE have probably more to do with how the maintenance department works rather than how the HSE manager works. So so that's the reality. And again, the standards prove it. So you don't have to say, Bruno said, Siveco says, believe me, just point to the standard that the two are related. So these are our, let's say, practical advices.